Hi. Recently, someone from Socratic.org asked this question: how does linear regression work in Excel 2013? I'm going to present three different examples of data which can be used to fit the data into a linear plot. So let's launch Excel, which I've got it here, and let's take the first example, which is the boiling point of alkanes. So I've got the boiling point of the first 10 alkanes, which can be obtained from any index or a textbook. So I've got the number of carbon atoms at the boiling point in degrees Celsius. So what I can do is I can select the data, go to Insert, here the chart, scatter plot. I need a scatter plot. There we go. So we've got the boiling point in the y-axis and the number of carbon atoms in the x-axis. So if we wanted chart axis, so we can use any of these format. Okay, let's choose this one that's got an axis title. So I can now write in the number of carbon atoms, and then for the y-axis I've got the boiling point of alkanes in degrees centigrade. Okay, so we've got all these points here. So I'm going to fit a trend line to fit it into a straight line. So let's see what kind of information we can get from this curve here. So it's pretty linear actually. There is a linear range, and then it's a curve here. There's a non-linear region here. So let's try to plot the whole data points into a linear regression and see what we can get. I'm going to right click and then add trend line, and then so I'm going to choose the trend line which is linear, and I'm going to display the equation on the chart and also the R-square value, which says how well the data is fitting into a straight line. So it's actually 97% correlation between the number of carbon atoms and the boiling points. So that's pretty good. So in this case, we can say confidently that the carbon atoms and the boiling point, they behave in a linear fashion. And if we were to find out the boiling point of the 11th alkane, so we could use the slope and the intercept of the curve that we have just done above to get the boiling point. So let's see, we've got the y is the boiling point, and the x is the number of carbon atoms. So let's write a formula. So equal to, so we've got 35.67 times we've got 11 carbon atoms minus 160.03. There we go. So for 11 carbon atoms, the boiling point is 231 degrees centigrade. Okay, so let's take two other examples. So the second one is so what I have now is, so this is a bit fancy, the same data, but in a slightly presented in a different way. So I have used this add-in called JChem, which you can get it from chemaxon.com. When I double click on that, so it launches the structure editor. So I can go and edit the structure, add a new structure, and I can say OK, and then it puts the formula of the compound in this little cell. So I can make it bigger, I can make it smaller just by altering the size of the row. Okay, and here we've got a formula based method to find out molar mass, and this one I've just used a formula and an ampersand operator to join the number of carbon atoms to create that. So C1H4, that means it takes 1 carbon and then 4 hydrogens, and this is just using the repeat function in Excel to indicate that you've got 1 carbon 2 carbons, 3 carbons, and so on. So I've done the same thing here, which you can see here. This is the plot of the boiling point versus the number of carbon atoms and the molar mass versus the boiling point. So I've got two different examples, just the data presented in a slightly different way using some of the Excel functions as well as the JChem add-in from Chemaxon. Okay, the last one is a growth curve of yeast. So this is a real data which is from my PhD thesis. So this is the optical density of yeast at 600 nanometers. So when the optical density increases, that means the number of yeast in the broth or the fermentation mixture increases. So that means the dry weight also increases. So I'm going to see if there is a linear correlation between the optical density and the dry weight. And I do the same thing like we did before for the boiling point data, and there we go, we get a straight line has got 97% correlation. And this coefficients, what it means is that 0.2, that's the growth rate of Saccharomyces cerevisiae, which is also known as baker's yeast. Okay, so just to go over what we did, so we started with the boiling point data. We inserted the curve just by using or sort of highlighting the cells, going to insert and then inserting a scatter plot, and then we right clicked the data points, and then we said add trend line, and then it brings us the option of linear, and then you put in the R square value and display equation and chart. So that's it. So I hope you understand the gist of it, and I hope you practice and get better at plotting XY plots. Okay, thank you for watching my video.